Hello guys, welcome to another lesson of social science with me, with the teacher Elena. Okay, so today we are going to continue explaining things about minerals and rocks. You can see there my poster of arts about what a family is made of. So the other days we learned what are the minerals. If you remember, the three properties of minerals are that they are inorganic, they are solid, they are natural. Okay, three things. Then we learn about the rocks. The rocks are made of minerals. Okay, they are also solid, they are natural, and they are inorganic, but they are different from the minerals because they are made of minerals. Okay, a rock is made of minerals. Yes, so we can find three types of rocks. If you remember, number 3 is always there. We can find three types of rocks. Yes, we can find igneous rocks, we can find sedimentary rocks, and we can find metamorphic rocks. Yes, we also learned that we can find igneous rocks near volcanoes. We can find metamorphic rocks deep inside the earth, unless there was erosion or an earthquake or a volcano, and then the metamorphic rocks go up in the surface. But normally metamorphic rocks, they are like deep inside. Then that we can find sedimentary rocks in the surface or of the earth or at the bottom of the ocean. Okay, the bottom of the sea, we can find sedimentary rocks. Actually, if you remember, the fossils like the ammonites and the trilobites, we can find them in the bottom of the sea because they were animals that lived in the sea. That's it. Okay, then we also know the layers of the earth. Thanks to Dr. Binox, we have 3 layers in the earth. Number 3 is magic. So we have the crust, we have the mantle, and we have the core. Okay, that's it. The crust is where we live, and it's made of rocks, minerals, and soil. Okay, that's it. So we stop there. What we're going to study now are the properties of minerals. The properties of minerals are like the characteristics of the minerals. Yes? The properties of the minerals can be used to identify different types of minerals, okay? So imagine you're like walking in the forest, like la, 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 and you find a mineral, and you have no idea what is that mineral. Well, knowing the properties of the minerals can help you to know what mineral you have in the hands, okay? So this year, we are going to study 3 properties of the minerals. Number 3 is magic. We are going to study the color, the shape, and the hardness, okay? Color, shape, and hardness. Let's see what your book says about it. Okay, we are on page 62 of your book. So, as always, pause the video and go and take your social science book. I wait. Okay, so now let's see what your book says. Properties of minerals. Minerals vary in their chemical composition and in their physical properties, such as color, shape, and hardness. What does this mean? Okay, the chemical composition means that everything in the universe, absolutely everything, is made of something called chemical elements, okay? Everything is like the smallest thing you can find in the earth. You cannot even see the chemical elements. You need a microscope, a very, very powerful microscope to see it, okay? So everything is done of chemical elements. I'm going to show you the chemical elements that we know that exist on Earth. Here we have the elements, and you will tell me, teacher, no. Yes, you don't have to learn them. You will see these in the high school. When you go to the high school, for the moment, the only thing you need to know is that you already know some of these elements. We know oxygen, we know carbon, we know iron, okay? We know many of these. They are not completely unknown. You know many elements of this table, okay? So the minerals can be made of many of these ones, okay? Each mineral has a different composition. One is probably made of, I have no idea, of fluorine and iron, another of cobalt and radium, another of, okay? So they can be made of different chemical elements. And depending on their chemical elements, they change their physical aspect. Let's see how. Their physical properties, they are color, shape, and hardness. Color. Minerals can be one color or they can be many different colors, okay? For example, the turquoise is blue, yes? The magnetite is black. And by the way, the magnetite is magnetic. That's why we call it magnetite, or that's why we call magnetic the things that are magnetic. Anyway, so the magnetite is magnetic, like the magnets of your fridge, like the magnets in the fridge, okay? So maybe, well, no, the magnets you have in the fridge don't have magnetite, but the magnetite is magnetic. So if you're walking in the forest, la 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 la, and suddenly something made of metal that you have sticks to a mineral, you know that that is magnetite. Okay, so the colors. Turquoise is blue, magnetite is black, and the quartz can be made of very, very different colors. We can find pink quartz, that is very common. We can find transparent or white quartz, but you can also find blue quartz. Actually, Alex Martin from 4th B has a blue quartz at home. He showed us yesterday in the video calls. So, okay, so that is the color. They can be made of different colors. So if, for example, if you find a mineral that is pink, it's probably quartz, but it's not magnetite, okay? So that you can make the difference there. Then, the shape. Minerals have different shapes. They depend on the elements, the chemical elements, which minerals are made up of, and how they are joined together. That means that depending on the chemical elements that a mineral has and how they are like connected, they make different forms, different shapes, okay? We can have, for example, have halite that has a cubit shape, halite, alita in Spanish, halite. Yes, like alita de pollo, but with H. Halite, and we also have aquamarine that has an hexagonal shape. That is, the halite would be like this. It's like a cube, and you will tell me, teacher, you cannot find a mineral that is like a cube. You can, and I have actually seen halite in the high school, and it's super cool because if you lick halite, it tastes like salt. So you can discover that it's halite by licking it. But if I were you, I wouldn't lick all the minerals that you find. And the aquamarine has this shape. It's hexagonal shape, okay? Like a prisma. Probably you are learning that with Cristina, or you are going to learn that. So when you learn this shape, remember that the aquamarine has this shape. You can tell Cristina, oh, Cristina, there is a mineral that has this shape. The aquamarine has this shape, okay? So that's it, the shape. They have different shapes depending on the chemical elements they have and how the elements are connected together, okay? We have the halite, cubic shape, and the aquamarine that has hexagonal shape. And the last property is very, very important, that is the hardness. Minerals can be hard or soft. Based on Mohs scale, Mohs! This man is famous. We have studied them. Do you remember Friedrich Mohs? Friedrich Mohs created something called the Mohs scale. Minerals go from 1, which is the softest, to 10, the hardest. Each mineral on this scale can scratch the previous one and be scratched by the following ones. You will tell me, teacher, what? Okay, I will explain you. We have a scale of different minerals. I'm going to show you the scale of Mohs, the Mohs scale. Give me a moment. Okay, here we have the Mohs hardness scale, the Mohs scale, okay? We have the number 1 is the talc, and the number 10 is the diamond, which means that the softest mineral is the talc, softest, más blando, and the hardest diamond is the hardest mineral is the diamond. That means that if I have a diamond, I can take the diamond and scratch, rascar, I can scratch the corundum. And if I have a corundum, I can scratch a topaz. Scratch means that I can take one and make like lines, scratches, okay? Scratches, arañazos, okay? I can scratch the topaz. If I have a topaz, I can scratch the quartz. If I have a quartz, I can scratch the orthoclase. If I have an orthoclase, I can scratch the apatite. If I have an apatite, I can scratch the fluorite. And if I have a fluorite, I can, and so on and so forth. And if I have a diamond, I can scratch the talc. All these ones can scratch the talc. That is the softest, okay? That is the softest one. That's it. So that means that the top of the scale, the number 10, that is the diamond, can scratch number 9. Number 9 can scratch number 8. Number 8 can scratch number 7, okay? And number 1, that is the talc, that is the softest one, can be scratched. I mean, the other minerals can scratch talc, all of them, because the talc is super soft, okay? More or less. So scratch is rascar, okay? Scratch. That means that you can make scratches, arañazos, yes? That's it. So the diamond can scratch all these ones, and the talc can be scratched by all these ones, more or less. That is the Mohs scale of hardness. Now, you have the talc here, that it says the softest mineral is the number 1 in Mohs scale, and you have the diamond here, that is the hardest mineral, that is number 10 in Mohs scale, okay? That's it, that's the lesson for today. Remember that you have to do exercise number 1 and exercise number 2. In exercise number 1, it says diamonds are the hardest mineral. What does this mean? You know it, I just said it. It means, full sentences, it means that diamonds can scratch all the other minerals in the scale. Yes? And the second one, it says, compare how hard minerals are. You have to write 5 sentences about how hard minerals are. Yes? So you have to say, for example, the diamond is harder than the corundum. The corundum is harder than the topaz. The topaz is harder. And then you have to say which is the hardest mineral and which is the softest. So you have to say the hardest mineral is the diamond. The softest mineral is the talc. And like that, the teacher has done the homework for you. You're welcome. Okay, so we will see each other in the next video. That is the last one, where we are going to study the uses of the minerals, how we can use minerals and rocks. And that's it for now. If you have any question or any doubt, please ask for help. You can write comments under this video, under this video, okay? Yes? Or you can write me in Dojo, or you can write me in Microsoft Teams, or you can write me in, I don't know, or you can send me a DAB, palomita mensajera, whatever you need, okay? But ask me the questions. Love you, goodbye.